All right, good morning, guys. So our lesson today is going to be a kind of a more or less a review of a chapter that we've already done. Now, we did this towards the beginning of the year. The chapter that we just finished, rational functions, had a lot of these types of equations and these functions in them. We're going to be dealing with nothing but quadratics today. And after I reviewed your tests and things like that, I went back and I saw that we were still struggling with the quadratics, so I decided to create this little mini unit, kind of hit quadratics real quick again before we move on to anything else. We've got the ACT coming up, so I just want to make sure that we are good to go with some of this content that happened so long ago, because we're still going to have chapters coming up that require you to be able to solve and know important information about these quadratics. So we're going to be dealing with quadratics. They're all going to be something with x squared or t squared, some variable to the second power. Okay. And if I look at this equation right here, it says that a water balloon is catapulted into the air so that the height h in meters after t seconds is modeled by this function right here. So we're going to have a quadratic function. And so before I look at any of the questions, what I'm going to do is I'm going to go ahead and just type that in my calculator real quick. Okay. And then I'm going to hit graph. All right. And what we're going to see is we're going to see a quadratic function that starts off and then goes really high in the air and then comes back down. So let's think about a water balloon. When it goes up, everything that goes up must come down. Remember when I talked about this in that chapter? Whatever goes up must come down. Okay, we've got this crazy thing in life called gravity. All right. So let's try to answer some of these questions now that we have a decent idea of what the graph is going to look like. Part A of this word problem right here says, how high is the balloon after 1 second? So they're wanting to know if this is where it starts at 0, 0, and the balloon is traveling up off the page, off the calculator, it eventually is going to come back down. The problem wants to know how high is the balloon after 1 second. So we're going to underline that. All right? What the problem is really wanting you to do is it's wanting you to take the equation and find the height. It tells you right here how high when the time is 1 second. So what it's really wanting us to do is take this variable t and substitute in a value. And in this problem, it wants us to substitute in the specific value 1. So what the problem is wanting you to do is it's wanting you to substitute in positive 1. So after 1 second, how high is the balloon? Well, let's find out. So once I type this in, my calculator tells me the answer is 24.5. So h equals 24.5. Now, without our units, this number is meaningless. Okay, it's just a random number out in existence. Without units, it has no meaning. So let's think about it. How high? What tells us that our units for this problem are going to be meters. Okay, so let's just put the letter m for the sake of time so that we can move on. 24.5 meters. Okay. For how long is the balloon more than 30 meters high? So this is actually going to be a little tougher than we think, because it's actually going to be an inequality because it says more than. So we're not going to be substituting any numbers in and straight solving. We're going to have to take this 30 meters high, and we are going to have to find how long the balloon is more than 30 meters high. So what it's wanting you to do is it's wanting you to find 30 for the height, and it's wanting you to solve for the rest. Okay? Now, I showed you a trick that if you didn't want to factor this, if you didn't want to use the quadratic formula, that if you subtract 30 on both sides, so as long as this is equal to 0, we can graph our new equation. Okay? And we can find, oh, that's going to be a subtraction symbol, so minus 6. So we can actually find for how long is this new function above 30. So what we're going to do is we're going to take this new equation, we're going to graph it, and that's going to help us find the intervals for which our original graph, so think back, we've got two separate graphs now, all All right? So it's telling us that we have two zeros for this problem. We have two time values. Okay? Our first time value is after 0.231 seconds. All right? The second zero for this, and guys, we've done a lot of these problems, so I know I'm going kind of quick. All right? The second time interval that it stops becoming above 30, so let's think about this in context of the problem here in just a second once I get this written down. 28 seconds. So what we just discovered is that after 2.31 seconds, the balloon was more than 30 meters high. And it was above 30 meters high all the way until this a little above 5-second mark. Now that's not the answer to our problem because the problem really wants to know for how long is the balloon. So 5.28 minus 0.231, which is going to give me a final answer of 5.049 seconds. So what we just decided is that this balloon is more than 30 meters high for a little over 5 seconds. And that's going to come back down to the ground very quickly, and it's going to end up hitting the ground, probably splattering all over the place. Okay? Questions?